Hi everyone, welcome to this Edexcel AS Mechanics paper 22 of May 2019. This paper is for a total of 30 marks and contains 3 questions. Let us get on with the questions. At time t is equal to 0, a parachutist falls vertically from rest from a helicopter which is hovering at a height of 550 meters above horizontal ground. The parachutist, who is modeled as a particle, falls for 3 seconds before her parachute opens. While she is falling and before her parachute opens, she is modeled as falling freely under gravity. The acceleration due to gravity is modeled as being 10 meters per second square. Using this model, find the speed of the parachutist at the instant when her parachute opens. So this is a constant acceleration situation, and we know that u equals 0, t is equal to 3 seconds, and acceleration due to gravity is 10 meters per second square. So let's put down what we know. U is equal to 0 meters per second. Time is equal to 3 seconds. Acceleration due to gravity is equal to 10 meters per second square. Therefore, using the equation v equal to u plus acceleration times t, we could write v equals 0 plus 10 times 3 equal to 30 meters per second. Part B. When her parachute is open, the parachutist continues to fall vertically. Immediately after her parachute opens, she decelerates at 12 meters per second square for 2 seconds before reaching a constant speed, and she reaches the ground with that speed. The total time taken by the parachutist to fall the 550 meters from the helicopter to the ground is capital T seconds. Sketch a speed time graph for the motion of the parachutist for time between 0 and capital T seconds. So let us draw the time and speed axis. This is the speed y-axis. This is the time on the x-axis. So we can say time in seconds. And here speed slash velocity, that will be in meters per second. Okay, so let's mark this arrow up here. Right, this is the y-axis, this x-axis. All right, so looking at the information that we have, let's jot down things inside this graph. So at the starting, when the parachutist falls or starts to fall, it is 0 velocity. Then after 3 seconds, so let's mark 3 here, right above that, she achieves a speed of 30 meters as we calculated in part A. And therefore we could write, okay, this one, that after that what happens is she decelerates, and that is for 2 seconds more. So let's write 5 here. So she must be reaching some velocity here which we need to calculate now. Right, and after that her velocity seems to be constant until she reaches the ground. All right, so that is t here, capital T. Okay. So how to calculate this velocity? So we again will use v is equal to u plus at. We do not know v, but we know that u is the speed from which she starts to decelerate. So that is 30 meters per second, plus deceleration is minus 12, and the time is 2 seconds, which means v equals 30 take away 24 equal to 6 meters per second, which is what this is, 6. And let's mark this also 0 and 0 to complete this diagram. Part C. Find it to the nearest whole number the value of t, the capital T value, which is the total time taken by her to hit the ground. So we know that the area under a velocity time curve will give you the distance traveled. Therefore, if we calculate this area and equate it with 550 meters, then there will be a function of t, so we can find out what the value of t is. So let's mark the task for us is to find t. Okay, so we will write the total displacement or the distance traveled is 550 meters is equal to area under the curve, under the velocity time graph. Therefore, area is equal to half times base times height for the first triangle, which is half times 3 times the height was 30, plus there is a trapezium, the two sides are 30 plus 6 divided by 2 times the height was also 2 because it was for 2 seconds. Then there is a rectangle there. That rectangle, the base is capital T minus 5 seconds times its width, that is equal to 6. The whole thing is equal to 550 meters. That is 45 plus, this is 18 times 2, 36, plus 6 times t, 6t minus 30 is equal to 550. Therefore, 6t equals 550 minus 45 minus 36 plus 30 is equal to 499. Hence, capital T equals 499 divided by 6, which is equal to 83 seconds to the nearest whole number. Part D. In a refinement of the model of the motion of the parachutist, the effect of air resistance is included before her parachute opens, and this refined model is now used to find a new value of T. How would this new value of T compare with the value found using the initial model in Part C? Earlier, the parachutist was falling freely under the force of gravity, but now the effect of air resistance is included. Therefore, the time taken will increase, hence we need to write T will increase. The new T value will be greater. Part E suggests one further refinement to the model apart from air resistance to make the model more realistic. There are quite a few refinements that we can point out, but most importantly, we could mention that the parachutist was modeled as a particle, but the parachutist will also have size and shape. And secondly, we could say we could use a more accurate value of the acceleration due to gravity. Instead of considering the parachutist as a particle, the dimensions of the parachutist could be considered. Or could be included in the model. Alternatively, you could also say a more accurate value for acceleration due to gravity could be considered. In the model. Only one of them is required. Question 2. A small ball P of mass 0.8 kg is held at rest on a smooth horizontal table and is attached to one end of a thin rope. The rope passes over a pulley that is fixed at the edge of the table. The other end of the rope is attached to another small ball Q of mass 0.6 kg that hangs freely below the pulley. Ball P is released from rest with the hook tight with P at a distance of 1.5 meters from the pulley and with Q at a height of 0.4 meters above the horizontal floor as shown in figure 1. Ball Q descends, hits the floor and does not rebound. The balls are modeled as particles, the rope as a light and inextensible string, and the pulley is small and smooth. Using this model, show that the acceleration of Q as it falls is 4.2 meters per second square. So I have captured the diagram here once again for the ease of our solving the question. So if you look at this, P and Q are connected particles, but they are having different directions of motion. Therefore, we cannot consider the whole thing as one system. So we need to write out the equations for motion for Q and P separately. So let's write for Q, it's going to be 0.6 G working downwards. And there is going to be a tension working on the other side. Okay, since this is moving down, we could say 0.6 G minus T is equal to 0.6 times the acceleration. We are following the equation F is equal to ma. So 0.6 G minus T is the resultant force and m is 0.6 times the acceleration. So for P, it's the tension that is pulling it towards the pulley. So we will write T minus, there is no frictional force here because it's a smooth surface. So let's write 0 here, okay, is equal to its mass 0.8 times the acceleration, which is the same for the whole system. Now, there is a minus T here plus T here. Therefore, if you add them, we can eliminate T. So that means adding 0.6 G equal to 1.4 A, leading to A equal to 0.6 G division 1.4. Putting into the calculator, we get 4.2 meters per second square. Part B. Find the time taken by P to hit the pulley from the instant when P is released. Here we have to calculate the time in two installments. First, the time taken by Q to reach the ground, and then after that the time taken by P to travel the remaining distance to hit the pulley. So for the first part of the journey, let's write S is equal to ut plus half at square. That means 0.4 meters equals u was 0, wasn't it? Plus half, acceleration was 4.2 meters per second square times t square. Therefore, 0.4 equals 2.1 t square, leading to t is equal to square root of 0.4 division 2.1, and that gives us 0.436 seconds. This is actually the time taken to move 0.4 meters. So let's write that. Time taken to move 0.4 meters is equal to this. So the remaining distance for P is equal to 1.5 meters, take away 0.4 meters, equal to 1.1 meters. The second part of the journey is also under constant acceleration, which is zero acceleration. Therefore, we could write S is equal to ut plus half at square for this leg of the journey as well. That means we will write 1.1 equals ut plus 0 because acceleration is 0. But we need to find out u here, then we can solve for t. So how to find out the u? U for P is the V for Q when it hits the ground. Therefore, let's figure out what will be V. V is equal to U plus AT, initial acceleration 0 plus 4.2, and we now calculated the time taken for Q2 moves 0.4 meters, that is 0.436 seconds, which is equal to 1.831 meters. Therefore, we can write 1.1 equals 1.831 meters per second times the time, and we are going to figure out what is this time now by dividing 1.1 by 1.831, which is equal to 0.6 seconds. Therefore, total time taken by P is equal to, the first time was 0.436 seconds plus 0.6 seconds, that's going to be 1.036 or 1.04 to 2 decimal places. Part C. State one limitation of the model that will affect the accuracy of your answer to Part A. Here we can safely say the rope, however thin, may have mass and this will affect the calculation done as per model. Question 3. A particle P moves along a straight line such that at time t seconds, where t is greater than or equal to 0, the velocity of P v meters per second is modeled as v equals 12 plus 4t minus t square. Find the magnitude of acceleration of P when P is at instantaneous rest. Here you have to differentiate the v function to find the a. So we can write a equals dv by dt, which is equal to 4 minus 2t, and then we need to figure out what's the acceleration when this object is instantaneously at rest. When it is at rest, v is equal to 0, right? Therefore, we can solve out what is the value of t. We can say 0 equals 12 plus 4t minus t square, which can be rewritten as t square minus 4t minus 12 equal to 0, and therefore it is t minus 6 times t plus 2 equal to 0. Therefore, t should be either 6 or t should be equal to minus 2, which is not practical. Therefore, we reject that. T cannot be minus. So, t is equal to 6 seconds. So, we will write here at t is equal to 6, a equals 4 minus 2 times 6 is 12 is equal to what? Minus 8 meters per second square. As the question is asking for the magnitude of acceleration, we could write magnitude of A equal to 8 meters per second square. That's the answer to part A of the question. Let's go to part B. Find the distance traveled by P in the interval t between 0 and 3. We know that the distance slash displacement is equal to integral of v with respect to t. So when it says t between 0 and 3, we need to write integral between 0 and 3 of the v function, which is 12 plus 4t minus t square dt is equal to, open a square bracket and keep integrating it, 12t plus 4t square over 2 minus t cubed over 3 between 0 and 3. Evaluating this, we get 12 times 3, 36, plus 2t square, that is 2 times 9, 18, minus t cubed, that is 3 cubed is 27 over 3, minus, since every term has got a t in it, it's going to be 0. Therefore, it's equal to 45 meters is the distance traveled. Hope this walkthrough was useful. We will meet in the next one. Till then, bye.